Welcome to your daily dose of enlightenment. You've landed on Knowledge Planet where curiosity thrives and the enigmatic is revealed daily. We delve into a variety of topics, shedding light on the hidden and sharing insights to amaze you. Consider us more than just a channel, we're a growing community, a family of knowledge seekers. We're on a mission to reach global corners, inviting you to join our exploratory. We need you, our growing family. In red, subscribe, become part of our community, share your thoughts, interact with us, a like or even dislike all count. Don't forget to stay updated, ring our notification bell, stay tuned, stay curious, and together we'll continue to explore the vast expanse of Knowledge Planet. A bottle of sparkling water has no bubbles yet, it's still sealed, but the moment we open it, why do the bubbles start to appear now? And then, why does a plastic bottle of sparkling water deform while one made of glass explodes? Look today, guys, let's see some aspects of sparkling water, how it is produced on an industrial level, and the difference with natural effervescent water. Spoiler, sparkling water is industrial, effervescent water is natural. So guys, for those who are not subscribed, know that it's free to subscribe. It doesn't cost anything. There are no strange things happening. It's a way to support us because it makes a huge difference for us. Thank you very much. And let's get back to it. Let's start by saying that most sparkling water is industrial, and the process for producing sparkling water is called carbonation. Basically, we need two fundamental conditions: low temperature and high pressure of carbon dioxide, CO2. Yes, water needs CO2 inside to become sparkling dissolved CO2. Low temperature is needed because carbon dioxide, CO2 dissolves better in cold water than in warm water. I know it may seem a bit counterintuitive, it's true. Like salt or sugar, it's the opposite, right? So the lower the temperature, the better the gas dissolves. And that's why carbonated beverages should always be kept in the refrigerator, because if we leave them out, they lose their fizz very quickly. The other element besides low temperature is pressure. The greater the pressure of the gas, therefore carbon dioxide, the faster the carbon dioxide will dissolve in the water. So in the process, we should have a high enough gas pressure to allow the dissolution of CO2. How is this done practically? Essentially, producers use a large pressurized tank with a perforated rod inside where carbon dioxide passes through. This is then injected into the water, which gradually absorbs all the CO2 possible. It's essentially very similar to the functioning of devices for making sparkling water that can also be installed at home. Now, when the water can no longer hold any more CO2, meaning we've reached saturation, it's said that equilibrium has been reached. This equilibrium means that the gas pressure above the liquid, between the water surface and the cap, prevents the dissolved CO2 in the water from escaping. That's why you don't see bubbles when it's still closed. The CO2 in the water can't escape because in this headspace, as it's called, there's already a high amount of CO2. In this next part, we're going to dive deeper into the intriguing world of sparkling water. Ever wondered why a frozen bottle of sparkling water either deforms or explodes? Well, it's all about the pressure. When a bottle of sparkling water is kept in the freezer, the water turns into ice and expands. Now, the carbon dioxide that was dissolved in the water is forced out due to the expansion of ice. However, it has nowhere to go because the bottle is sealed. This causes an increase in the pressure inside the bottle that leads to deformation or even explosion. Interestingly, this is not the case with regular water bottles. In regular water, there's no dissolved carbon dioxide to create that pressure. So a frozen bottle of regular water will simply expand a bit, but won't deform or explode. But let's get back to our sparkling water. When the bottle is opened, the high pressure is released, and this is what causes the explosion. The pressure was so high that the carbon dioxide rushes out, taking some of the water along with it. This is why you see a gush of water shooting out when you open a frozen bottle of sparkling water. So the next time you put a bottle of sparkling water in the freezer, remember the science behind it. It's not just a bottle of water, it's a mini science experiment waiting to happen. Stay tuned for more such fascinating facts. Let's unravel more mysteries in the next scene. In this scene, we're going to delve into our scientific aspects of sparkling water. As we've mentioned before, the carbon dioxide dissolved in sparkling water plays a significant role in its behavior, especially when it's frozen. But did you know that it also influences the pH level of the water, making it acidic? When carbon dioxide dissolves in water, it doesn't just sit there idly. A portion of it reacts with the water to form carbonic acid, which is represented by the chemical formula H2CO3. This is the reason why sparkling water tastes slightly tart compared to regular water. Now, you might be wondering, does that mean sparkling water is harmful to my teeth? Well, while it's true that acids can erode tooth enamel over time, the amount of acid in sparkling water is quite minimal. So, unless you're chugging down gallons of it every day, your pearly whites should be fine. But remember, everything in moderation is the key. In the next scene, we'll continue to uncover more fascinating facts about everyday phenomena. Stay tuned. Indeed, the pH of sparkling water is around 5.6. Now, for those unaware, pH is a scale that measures how acidic or basic a substance is. A pH below 7 means it's acidic, while a pH above 7 indicates it's basic. Natural water usually has a pH around 7, which is considered neutral or slightly basic, around 8. So, by this measure, sparkling water is indeed more acidic than regular water. But before you start worrying about your stomach or your teeth, let's delve a little deeper. The acidity of sparkling water isn't potent enough to cause stomach problems. As for your teeth, a 2017 study conducted by the American Dental Association showed that it would take over 100 years of continuous use, so every day, drinking sparkling water to cause damage to the teeth. That's right, you would have to drink sparkling water every single day for more than a century to see any significant harm to your dental health. So we can relax and enjoy our sparkling water without worry. But remember, balance is the key to a healthy lifestyle. In the next scene, we will dive into the history of sparkling water and how it became a popular beverage choice. Stay tuned. Having understood the chemistry and pH of sparkling water, let's now delve into understanding the difference between sparkling water and natural effervescent water. You might be wondering, isn't all carbonated water the same? Well, not exactly. Sparkling water becomes effervescent through an industrial process, meaning carbon dioxide, or CO2, is added to it. On the other hand, natural effervescent water is slightly sparkling right from its source. Yes, you heard it right. Some water springs naturally produce effervescent water. But how does this happen? Well, before emerging from a spring, water can have a more or less long path underground, even for years. During this time, it comes into contact with various types of rocks. With certain rocks, water can absorb a quantity of CO2 such that it becomes naturally effervescent. The effervescence, or the bubbles you see, are a result of the release of this absorbed CO2 when the water comes to the surface and experiences a decrease in pressure. So while the end product might seem the same, the journey of sparkling water and natural effervescent water is quite different. Isn't nature fascinating? In the next scene, we will look at how sparkling water became a popular beverage choice. So stay tuned to continue your journey on the knowledge planet. Moving on from the natural phenomenon of effervescence, let's take a sip into history and find out how sparkling water became a popular beverage choice. You might not know this, but people have been drinking sparkling water for centuries. It was once considered a luxury item, enjoyed only by the elite. It all started with natural effervescent water, which was found in springs and was believed to have medicinal properties. This idea was so popular that people would travel to these springs, known as spa towns, to take in the healing waters. As time went on, the desire to recreate this naturally effervescent water led to the invention of a process to artificially carbonate water in the 18th century. This was a game changer, making sparkling water accessible to everyone. In the 20th century, the rise of soft drinks saw a decline in the popularity of sparkling water. However, in recent years, with people becoming more health conscious, sparkling water has made a comeback. It's now seen as a healthier alternative to sugary drinks, offering the same fizzy satisfaction without the calories. So, whether it's a can of your favorite brand or a glass from a natural spring, the next time you enjoy a sparkling water, remember the fascinating journey it has taken to get to you. And remember, whether it's natural effervescent water or artificially carbonated, each bubble is a testament to the marvels of science and nature working together. Did you know all this? Let us know in the comments, and don't forget to subscribe to Knowledge Planet for more fascinating insights. See you in the next scene. Okay, folks, we've quenched our thirst with sparkling water and its fascinating history, but let's pause for a moment and take a look around us. Here at Knowledge Planet, we're not just about feeding your curiosity, We're about building connections. In this whirlwind of a world, staying connected has never been more important. Here, you've found a place of engaging content, community, and shared experiences. Think about it. When you subscribe, you're not just joining a channel, you're joining a family that grows with every click, every share, every comment. So don't be a stranger. Dive into the conversation. Add your voice to the mix. Agree, disagree. All perspectives are welcome here. And remember, sharing is caring. Pass along our videos to friends who could use a laugh, a moment of insight, or just a break from the everyday. Oh, and one more thing. That little bell icon, it's your ticket to never missing a beat. Click it, and you'll be the first to know when fresh content hits the airwaves. So subscribe, comment, share, like, or even dislike, and ring that bell. Here's to growing our family, one video at a time. Stay tuned for more, and as always, keep exploring, keep questioning, and keep learning with Knowledge Planet. See you in the next scene.